So 1.3, just like 1.1 and 1.2, it's kind of a review of things that you have done before. So we start off with the domain and range of a function. The domain is going to be our x values, and the range is our y values. So to find the domain, we're going to go from left to right. And to find the range, we go up and down. So here's an example. Our domain is anything the graph touches going left and right. So to find the domain here, we start all the way to the left of our graph and go right. So the first thing we hit when we go from left to right is going to be this point, which is at -1. Since it's a closed circle at -1, we're going to put a bracket. And then our graph keeps going and stops at +4. But since it's an open circle there, we put a parentheses. So our domain is -1, 4. Our range, actually next let's find the function values. Give me one. All right, so for b here, we need to find f of -1 and f of 2. So here, for f of -1, this is like saying f of x is equal to y. So inside here, this is our x value, and we need to find when x is -1, what is y? So going to our graph, we look here at x is -1, we see that y is -5. So f of -1 is -5. The second one is f of 2. So we go to where x is 2 on our graph, and we see that when x is 2, y is 4. So f of 2 is 4. So just know that when it's inside the parentheses, that's our x value, and when x is that value, it gives us this y value. Okay, and then part C asks us for the range of our function. So the range, we start down low and go up. So our graph starts when y is equal to -5. We see that this is a closed circle here, so we put a bracket. And then our graph ends. The highest point of our graph is up here at 4. And we're going to put a bracket there as well. So our range is -5 to 4. Any questions so far? Okay, looking at number 7, right below. Use the graph of the function to find the domain and range of f, then find f of 0. So our domain is going to be everything from left to right. So we see that our graph keeps going in this direction. So as we get bigger, our graph is still going to be there. So our domain is going to start at -infinity, and it's going to end at +infinity. Another way of writing this would be all real numbers. And when you write the domain and range using infinity, it's always going to be the parentheses. So you wouldn't put a bracket infinity, it'll always be parentheses. Next we have our range. So our graph we see is going down forever. Those arrows just show that it's always going downwards. So it's going to start at -infinity, and then our highest point here is at positive 1. So our range is going to be from negative infinity to 1. And then the last thing it asks for is f of 0. So we look at our graph and we see when x is equal to 0, what is our y? So that's going to be this point up here. So when x is equal to 0, our y is 1. So f of 0 is 1. For number 9, our domain is from left to right. So our graph starts at this -4 point. So we're going to put a bracket, -4, and then our graph ends at +4. So our domain is -4 to 4. Our range, starting at the bottom and going up, our lowest y value here would be 0. Our graph starts at 0. And then our highest y value is this point up here, which is +4. So our range is 0 to 4. And then f of 0, we see when x is equal to 0, our y is 4, so f of 0 is equal to 4. Any questions?
How do you know when to put a bracket or a parentheses?
So the only time you'll put a parentheses is when you have infinity, like here. So when it's negative infinity or infinity, you'll put a parentheses, or when you have an open circle. So like for the first example, we had an open circle, so that's why our 4 had an open circle, a parentheses there. So when it's an open circle, you put a parentheses.
Gotcha.
So the bracket just means that it's like including that number. Okay, sometimes it doesn't give us the graph, but it'll still ask us for the domain and range. So if it just gives us f of x is equal to the square root of x minus 4, we can still find the domain and range here. We just have to solve it algebraically instead of using the graph. So we know that what's inside our bracket can never be negative because we can't take the square root of a negative number. It'll give us an imaginary number, which we don't put imaginary numbers on our graph. So what's inside of our square root has to always be positive. So x minus 4 always has to be greater than or equal to 0. Now to find out what our x values are, we need to get x all by itself, so we're going to add 4 to both sides. So we have x is greater than or equal to 4. So since x tells us our domain, we said our domain is all the possible x values. We know that our domain here starts at 4, and we put a bracket since this is greater than or equal to. And then we have no restriction on the higher side of x, so x could be anywhere to infinity. So -4 to infinity. I mean +4 to infinity, I'm sorry. So our domain is a set of all real numbers greater than or equal to 4. Moving over to the right side of our page, we have a few examples. So we have number 11, f of x is equal to 2x squared plus 3. we know that this graph is going to look like a parabola because it's an x squared graph. So let's say we plug in 0. So we have 2 times 0 plus 3. When we plug in 0, we get 3. So when our x is 0, our graph starts at 3. So our graph is going to look something like this. Now to find the domain, we go from left to right. Our graph is continuously going in the left direction, so we're going to start with negative infinity, and it continuously goes in the right direction, so our domain ends at infinity. Which again, another way of writing this would be all real numbers.
Miss Carter,
Yes.
why is the x value a negative infinity and not a positive?
So it starts, so we always go from left to right when doing the domain. So we're always going to start with our smallest x value to the left and end with our largest. So we see that this arrow is going in this direction, so it's always going left. So the farther it goes to the left, it's just getting smaller and smaller, so that's why we start with negative infinity. And then this one is always going to the right, so it's getting bigger and bigger, and it'll end with positive infinity.
Thank you.
Now our range, we start with the smallest y value and go to our biggest one. So what's our smallest y value of this graph? So if we start down low and go up, where does our line first touch the graph? At 3. So our range starts at 3, and then our graph keeps going up and up forever. So what's the end of our range?
Infinity.
Infinity. So that's all we needed to do. Find the domain and range. Now moving on.
We don't put a bracket at the end. We put a parentheses.
Always when you do parentheses, always when you do infinity, it'll be parentheses.
Oh, okay.
So every time you put negative infinity or infinity, it'll always be a parentheses. All right, 13. Just like in the first example we did, we know that x minus 1 has to be greater than or equal to 0. Since it's under that square root, we can never have a negative under the square root, so x minus 1 has to be greater than or equal to 0. So to find what our domain is, we need x to be all by itself, so we're going to add 1 to both sides, so we have x is greater than or equal to 1. So x is going to be all of our values that are greater than or equal to 1. We know that our domain goes with our x values, so what's our starting domain? What is the smallest x value that this graph can have?
1.
1. Are we going to put a bracket or parentheses? Bracket. And we put a bracket because this is greater than or equal to, so it's including 1. What's our highest value that this graph can have? Our highest x value?
Infinity.
Infinity. And we put a parentheses because we have infinity. Now with our range, we kind of have to think about how, let me write it on the side here. So our problem is f of x is equal to square root of x minus 1. We have to think about what values this f of x can have. We know that if we have a square root, our y values are never going to be negative. So we're never going to take the square root of a number and get a negative number. So it always has to be a positive number. So let's see. If we plug in 1, let's just say, because our x values can't be anything less than 1. Give me 1 second. My pencil just decided to stop working. Okay, and then for 15, we're doing the same thing. So our graph of an absolute value is going to look like a V. To determine where we start, I'm just going to plug in 0. So let's do f of 0 is equal to the absolute value of x plus 3. When we plug in 0, we have so f of 0 would be 0 plus 3. This would be 3. We know that our graph isn't going to look like this, so let's plug in -1. So f of -1 is going to be -1 plus 3, which is 2. So right now, all I'm doing is plugging in points to see what our graph is going to look like exactly. If I plug in -3, we have -3 plus 3, which is 0. There. And then if I plug in -4, I get 1. So this is where our graph is going to be. So our V is just going to start shifted 3 units to the left. Now to find our domain, we just look at our graph. So what's our smallest x value that we have here?
Is it -3?
So our smallest x value is going to be the smallest thing to the left. So remember, our domain goes from left to right, so smallest to largest. We see that this arrow keeps going to the left forever. So our domain starts at -infinity. And then what's our domain going to end at? Infinity. And we put parentheses. Now for our range, we start at our smallest y value and go to our largest. So where does our graph start?
0.
0, perfect. And where does our graph end? Going up?
Infinity.
Infinity.
Why did you put the bracket in front of 0?
Because it's including 0, so the only time that we put open parentheses, so like this, we only do that when we have infinity or if we had a hole in our graph.
Thank you.
You're welcome. Okay, moving on to the vertical line test for functions. So we use the vertical line test to decide whether the graph represents a function. So vertical line, it's so much easier to like show people in person, but if you just take your pencil vertically and go over the graph, if the pencil touches 2 points on the graph, then it's not a function. So the vertical line test can only touch the graph at 1 point at all times. So looking at example A here, we see that our vertical line touches the graph twice, so this would be not a function. For B, if we take a vertical line starting from left to right and going over our graph the whole time, it will only touch the graph at 1 point always. So this would be a function. The next one, if we take our vertical line and go over the graph, it will only touch the graph at 1 point from left to right always. So this would be a function. And then what about the last example? What do you guys think?
Not a function?
Not a function, because if we put a vertical line over it here, it touches in 2 points. So this would be not a function. All right, next we have increasing and decreasing functions. So just like how you read, you go from left to right. Going from left to right, if our graph goes down, it's decreasing. If it's flat, it's a constant. And if it goes up, it's increasing. So in example 4, determine the open intervals on which each function is increasing, decreasing, or constant. So the open intervals that we have here is always going to be our x values. So in determining if it's increasing, decreasing, or constant, when we write our intervals, we look at the x values. So for A, starting from left to right, our graph is always going up. So this would be increasing, and then it would be increasing on the intervals from -infinity to infinity, which we could write this as all real numbers. So this graph is always increasing. For B, we see that our graph is increasing until it gets to x is equal to -1 right here. So it's going to be increasing from -infinity to -1. And here, when writing the intervals, if it's increasing or decreasing, we always put a parentheses. So at -1, it's neither increasing nor decreasing since it changes, so we don't include that point. So that's why we put the parentheses instead of the bracket. Then from -1 to +1 here, it goes down, so we're decreasing. So it would be decreasing on the interval from -1 to +1. But then our graph changes again and starts going back up at +1. So again, it's increasing from +1 to infinity. So remember, we're always looking at the x values to tell us what our interval is going to be. So that's why here we look at this value of -1 and we look at this value of 1. So just the x values. Looking at example 3, we see that our graph is going up here until what point? So it's increasing from -infinity to when does it stop increasing? 0. And then from 0 to what point is it constant?
2.
0 to 2. And then from 2 to what point is it decreasing?
2 to infinity.
To infinity. So 2 to infinity, it's decreasing. Any questions? All right, next we have relative max and min. So the relative max is where it changes from decreasing to increasing or increasing to decreasing. So relative max is always going to be our peaks of the graph. So this high point where it goes increasing to decreasing or increasing to decreasing. And then our relative min is always going to be the valleys. So when it goes decreasing to increasing. So looking at our example down here, our relative max would be this point. And then our relative min would be the valley that's down here. This one's the same exact thing, so. Just know that the relative max is like the top of the mountain, relative min is the low point. Any questions? Okay, next we have piecewise functions. So here in piecewise functions, our graph is kind of split up into two different graphs. So when we have x, when x is any value that's less than or -1, our graph is going to look like this. When x is any value that's greater than 1, our graph will look like this. So we kind of just have to take it and split it up and think of it as two different graphs. So looking at our first example down here, 55. So the first thing we're going to do for piecewise functions is take our first graph. So we have this 2x plus 3, and we're going to start with our restriction that it has. So this is when x is less than 0. So we're going to plug in 0 and see what value y is here. So we're going to plug in 0. So we have 2 times 0 plus 3. So when x is equal to 0, our graph is 3. But one thing that I forgot to mention, looking up here, if we have a less than or negative sign, that's when we have a closed circle. If we have less than or equal to, or greater than or equal to, if it has this equal to thing, that's when we have a closed circle. If it's just less than or greater than, that's when we have an open circle. So first example, we have just a less than with no equal to, so we know that this is going to be an open circle. So at 0, we have an open circle here. Now we're going to plug in any value that satisfies this x is less than 0. So we can pick any number that's less than 0 and put it into our equation. So the next thing we're going to plug in, we can pick -1, -2, -3, any number that's less than 0. So let's just do -2. So we have 2 times -2 plus 3. So this would be -4 plus 3, which is -1. So when we plug in -2, so when x is -2, we get y is -1. So 1 point of our graph is going to be there. And then we know this is a linear graph, so we can just connect these 2 dots with a line. So that takes care of our first part of our graph. Now we need to look at the second part of our piecewise function. So this is when x is greater than or equal to 0. Again, we're going to plug in the first part of our restriction, so we plug in 0. So we have 3 minus 0, which is 3. So on our graph, when x is equal to 0, y is 3. Here we have that greater than or equal to, so we put a closed circle. And now to tell us what the rest of our graph is going to look like, we're going to pick any number that satisfies this. So any number that is greater than or equal to 0, which we just did 0. So any number greater than 0, we can pick, well, let's pick +2. So x minus 2 would give us 1. So when x is +2, y is 1. All right, and we're just going to connect these 2 with a line. So that is our first graph for 55. Now looking at 57. So again, we start by plugging in our ending value here. So when plugging in 0, we have f of 0 is equal to the square root of 4 plus 0. F of 0 is equal to the square root of 4, which is 2. So when x is equal to 0, y is equal to 2. So we're going to go up 2. Now to determine if it's an open or closed circle, we look at our greater than or less than sign. This is just less than with no equal to, so it's going to be an open circle here. Now we need to plug in another number for x that is less than 0. So we can plug in any number, but we need to know that this graph has restrictions on its domain. So we see that since it's a square root, what's under the square root has to be greater than 0 because we can't take the square root of a negative number. So we have 4 plus x is greater than or equal to 0. So we're going to subtract 4 on both sides, so we get x is greater than or equal to -4. So x is going to be any value bigger than -4 but less than 0. So let's plug in -4 so we can see what our ending value is for this graph. So f of -4 is equal to the square root of 4 plus -4. 4 plus -4 is 0. Square root of 0 is just 0. So when x is -4, y is 0. So we're going to go to the left 4 and put a dot there. And now we know our square root graphs kind of look like this. Now for the second part of our piecewise function here, it's when x is greater than or equal to 0. So we're going to start by plugging in this 0. And we plug it into our second function here. So f of 0 is the square root of 4 minus 0, which is the square root of 4, which is 2. And then we see this greater than or equal to sign. So we're going to put a closed circle here. So when x is 0, y is 2. Now again, we have restrictions on this domain. So we have 4 minus x has to be greater than or equal to 0 because we can't have a negative number under the square root. So we're going to add x to both sides. So we have 4 is greater than or equal to x. So I'm going to plug in 4 to see what our ending of this graph is going to look like. So when x is equal to 4, we plug it into the second function down here. We have the square root of 4 minus 4, which is the square root of 0, which is just 0. And we're going to connect our graph like that. So this is our graph for 57. Next we have 59. So here we have 3 parts of our piecewise function. So looking at the first part, we're always going to plug in our ending of our restriction here. So x has to be less than or equal to 0. We're going to plug in 0. 0 plus 3 is 3. So when x is equal to 0, y is equal to 3. So we're going to start with that on our graph. And we see that we have a less than or equal to, so we know it's going to be a closed circle. Closed circle. Okay, there we go. So when x is 0, y is 3. We put a closed circle there. Now we're going to plug in another number that's less than 0. So we can just plug in, let's say, negative 2. So f of negative 2 would be negative 2 plus 3. Negative 2 plus 3 is 1. So when x is negative 2, y is 1. So we're going to go to the left 2 and up 1. We know that this is a linear function, so we put a line connecting those 2 dots. Next, we just have a constant number 3. So we know that from 0 to 2, our graph is going to be a constant at 3. So we start when x is equal to 0. We have just a less than sign, so we know this is going to be an open circle. And then it goes until 2. And this is less than or equal to, so this will be a closed circle. And then we just have a flat line connecting those 2 dots. And then lastly, we have when x is greater than 2. So we're going to start by plugging in 2. So we have 2 times 2, 2 times 2, minus 1, which would be 4 minus 1, so 3. And then it's just a greater than sign, so it's going to be an open circle. So we have an open circle when x is 2, y is 3. And now we're going to plug in any number that's greater than 2 to give us a general direction of where our graph is going to go. So we can plug in, let's say, 3. So we have 2 times 3 minus 1. This will be 6 minus 1, which is 5. So when x is 3, y is 5. And then it's a linear graph, so our line's just going to go up like that.